Hello, and welcome. In today's tutorial, we will cover an introduction to the new GPX Paradigm and demonstrate how to create a project from scratch. I want to start with a very fundamental question. What goes into a simulation? In real life, when a drug is administered to a patient, we have several elements. The compound itself, how it is formulated, how and when this formulation is dosed, and who it is dosed to. Of course, we also have ADME, or the pharmacokinetics of how that drug behaves in the subject's physiology. Naturally, a simulation is comprised of all these same components. In GPX, each of these components is represented logically as an individual building block, called an asset in GPX terminology. Assets include experimental data, compounds, formulations and doses, physiologies, schedules, and pharmacokinetic parameters. These assets are brought together to form one or more simulations. All of these assets operate independently and are brought together in a simulation. Numerous simulations can be created by combining different assets, and multiple simulations can be run simultaneously. Individual assets can be shared and reused between different simulations, simplifying the model building process. It is also important to note that simulations have settings and a configuration. Settings control how the assets are used in that specific simulation, and the configuration addresses computational setup. Let's discuss settings in more detail. As mentioned, simulations have both assets and settings. Assets, in turn, have properties, which are real values, be they measured or predicted, that are used as simulation inputs. Settings, in turn, dictate how these values are applied within the simulation. For example, solubility is a property of a compound, and this numeric value goes into the simulation. A related setting is which solubility model should be used in the simulation: the default Henderson-Hasselbalch equation or interpolation of measured solubility data. Similarly, pH values and transit times in the gut are properties of a given physiology, but the ASF model used is a setting selected at the simulation level. Pharmacokinetics are a bit of a special case in GPX, as they are properties of a compound physiology pair. For example, a compound may have different distribution and clearance in rats versus humans, so these properties are specific to each species' physiology for that drug. Likewise, two different compounds may have different tissue partition coefficients, even when paired with the same physiology. Additionally, because compartmental and PBPK parameters can exist side by side in GPX, one PK model must be selected when creating a simulation.